So first off, what is advanced footwear technology, AFTs, or as some of you might better well know them, super shoes? These shoes have a couple defining characteristics. They are made to be performance enhancing. They have lightweight, resilient midsole foams, rigid moderators like a carbon fiber plate, as you see there, and a pronounced rocker profile. So when we talk about the performance enhancing, that's for endurance performance, which has a couple of important determinants. When we look at the main three, we have VO2 max, which is your maximum aerobic capacity. This is the maximum amount of volume of oxygen that you can intake during exercise. This isn't an intensity that you can hold for very long, which is where lactic threshold comes in. This is the percent of your VO2 max that you can run sustainably, something that you can maintain for a longer amount of time. And the one that we'll be focusing on for the purpose of this study is running economy, which is the oxygen cost required to run at a given speed. Taking a closer look here at running economy, we are hoping to see an improved running economy with these shoes. And so that can be indicated by a reduced VO2 or energy expenditure at a given speed. At this top graph here, we can see that this individual with their now improved running economy in that orange line, we can see that at the same speeds, they have significantly less energy being used, less oxygen, less effort, and it's almost like getting more miles per gallon in your car. At the bottom graph here, we can also see that improved running economy allows for faster speeds to be reached for the same physiological intensity. Looking at this white line here at that set VO2, their improvement allows them to run almost an entire half mile per hour faster for the same physiological intensity, the same oxygen cost. So how do running economy and AFT shoes relate? Right now, previous studies on AFT road shoes have indicated a 2.7 to a 4% benefit in running economy. These technologies have recently started to be incorporated into trail shoes, though their benefit has not yet been quantified. And it's important that we look at the trail shoes separately as compared to making a blanket statement about AFTs because of the difference in the terrain. There's less stability on the trails, which means less points of contact for the shoes, as well as people tend to run slower on the trails. AFT road shoes are often tested at marathon pace or faster, but for trail races, we are often looking at ultra marathons, things over 26.2 miles per hour. 26.2 miles. And so the purpose of our study is to determine the effect of an AFT trail shoe on running economy relative to a traditional trail shoe over the trail and treadmill surfaces. So the way that we did that was we had 8 experienced distance runners that met a specific set of criteria come out for 2 separate visits. Their first one was on the trail. As you can see here, this map shows the trail that we used at the Wild Basin, the Aurora Vista Loop. And then 1 to 2 weeks later, they came to the Endurance Performance Lab here on campus to do trials on the treadmill. For both of their visits, they completed 4 by 1,500 meter reps in both the AFT and control shoe. For this, that was 2 laps of the loop up there, and they also had 5 minutes in between each rep just to allow time to change shoes and to properly recover. As far as the shoes tested, the advanced footwear technology shoe that we used was the Nike Ultrafly Trail, and the control shoe was the Saucony Peregrine 13 Trail. They were tested in duplicate, meaning that they were tested in either an A-BBA sequence or B-AAB. The most important thing being that the first and the last were the same and the 2 in between. They tested in the same sequence for each of their 2 visits, and this was counterbalanced across subjects, just meaning that we had 4 participants test at the top sequence and 4 participants test on the bottom sequence. For the purpose of the study, running economy was calculated as VO2 expressed as cost of transport, which is milliliters per kilograms per kilometers. VO2 was measured by a calibrated metabolic device, a portable metabolic device, as the one that you see here. It's just the mask that they wore during the trials. And the running mechanics were measured by a Garmin heart rate strap with an accelerometer. The average values of their last 1,000 meter reps of their 1,500 meter trials were calculated both for VO2 and their running mechanics. And the reason that we used the last 1,000 instead of the entire rep is this gave them time to reach a steady state or consistent level of intensity, which allowed for us to take more accurate measurements, a more accurate assessment. On the trail, their speed was self-selected 50K race effort, just meaning there was no means by which that we paced them individually. It was completely effort-based. As for the treadmill, their speed was fixed to match the average of their speed on the trail. And running economy was calculated with a 2-way repeated measures ANOVA test. So looking at this first round of results, this is just showing the cost of transport between the two shoes, both on the different surfaces. We have cost of transport here on the Y. We saw a significant main effect for surface, with the treadmill providing a 5.2% cost of transport benefit relative to, or compared to the trail, and this was independent of shoe. And we can see that represented on the graph here, with our treadmill line being much lower on our graph, where we see much lower cost of transport values compared to our trail, much closer to the top there. We also saw no significant main effect for shoe, but we did see on average a 1% benefit to cost of transport in the AFT shoes compared to the control shoe. This was independent of surface, which just means that there was no surface by shoe interaction, as we saw almost identical benefits from the AFT shoe in both surfaces, with a 1% on the trail and a 0.8% benefit on the treadmill. We can also see both of these on the graph, as we see our lines trending slightly lower towards the AFT, showing us that benefit, as well as the almost identical slopes in the line, which are indicating those identical benefits. Looking at this table here, we're looking at cardiovascular and running mechanics between the two shoes. Again, we have cost of transport at the top, where we can see that significant difference in lowering on the treadmill compared to the trail. This is also mimicked in the VO2 data, as they are both expressions of running economy. Something that we found interesting was down here at the stance time percent, which is the percent of time that you spend on the ground compared to in flight. We see a statistical significance for shoe, meaning that those AFT shoes did provide a lower stance time percentage, which is often thought to be more economical, because the less time that you spend on the ground is the more time that you're moving forward and in flight. We thought that this was interesting because this would attest to a running economy benefit from the shoe, but that's not something that we saw mimicked in almost any of the other metrics. I'd also like to point out here at the bottom, looking at our speed for the trail, we see a negligible difference between the speed with the two different shoes, just meaning our participants, those effort-based, were very consistent and weren't favoring one shoe over the other. And so the main takeaway from our study at the moment is that trail super shoes had a moderate effect on running economy relative to a traditional trail shoe, although it's non-significant with the current sample size. And the reason that, even though we don't see a statistical significance at the moment, that we can still claim a moderate effect is because of this number down here, Cohen's d-C. That's within subject effect size. It just allows us to look at the magnitude of the effect independent of sample size. This number here of 0.65 tells us that we would expect to see a moderate effect shown statistically as we expand the sample size to something about 16 subjects, which is the next steps for this study as we spend the next month or two collecting more data to hopefully see that significance. How does this compare to current AFT research? As I mentioned earlier, the road shoes that are currently being tested have seen a 2.7 to a 4% benefit in running economy. This study here was done in 2018, looking at the Nike Streak, Adidas Boost, and the Nike prototype at the time that would go on to be the Nike Vaporfly. We can see on our graph over here the almost identical energetic cost between the Nike Streak and the Adidas Boost, where we see that significant benefit to the energetic cost in that Nike prototype that becomes more exaggerated as the speed increases. Another study on AFT road shoes shows that they had a diminished benefit to running economy at slower speeds, looking at 10 and 12 kilometers per hour compared to the 14 to 18 tested in the previous study. As you can see here, we're looking at a 0.9% to a 1.4% benefit in running economy, which, while still significant, is far less than we saw at faster speeds. So what does this mean for our results? Since we saw no difference in the AFT benefit in trail and treadmill shoes, it is likely that this reduced benefit is due to the slower speeds tested, as opposed to for a surface effect, as we were testing at about 11.5 kilometers per hour, which is lower than that study showed those effects at faster speeds. Because of smaller magnitude, even if we were to expand the study out, we wouldn't expect to see a large increase in that magnitude of the benefit, as well as we would not expect to see any sort of difference between the benefit on the trail and on the treadmill. We chose to do a self-selected pacing. You could argue that there may be a greater benefit at faster speeds, but doing so would negate the fact that people just tend to run slower on the trail. So I would like to first and foremost thank my mentor, Dr. Jobert. I never saw research as a part of my undergraduate experience, and now this is the third project that we've worked on together, and it has been the best opportunity and privilege to get to learn from you. I would also like to thank the St. Edward's Kinesiology Department and the Endurance Performance Lab for providing me with the knowledge, the resources, and the support to be able to do these projects. A huge thank you to the Wild Basin Wilderness Preserve, not only for allowing us to use their trails for this study, but this project was also funded by the Hooks Endowed Wild Basin Creative Research Fund. So because of the Wild Basin is why we were able to do this in the first place. Lastly, I'd like to thank all of the support that I've had here at St. Edward's from teammates, friends, coaches, professors along the way, and most importantly, my parents, who are the reason I'm standing up here today. Thank you. I think the most interesting thing was the fact that we didn't see a difference in the benefit between the trail and the treadmill, because one of the reasons that we tested for the trail shoes apart from the road shoes is because we were expecting the terrain on the trail to change the type of benefit that they were getting from those certain technologies, because some of those are based off of like force and your points of contact and how much energy you're receiving back. So the fact that we didn't see a difference in the benefit between those two surfaces was something that I found really interesting.
Do you think there are ways to improve the trail shoes, like more advanced technology so that they're even better? I mean, are there ways to make the effect bigger on the trail, I guess?
At this point in shoe research, these shoes have most of the effects that you would expect to see in a road shoe, like minus things like the pronounced rocker profile, which would affect the stability of the shoes on the trail. So I don't know if there's, from the technology side, if there's a lot more that can be done, other than advancements in the type of foam that would allow them to provide that energy return at slower speeds. We did, so it was less of a preference, but on this chart here, we took RPE, which is just their perceived effort, and it's self-reported by the participants, and we saw statistically lower RPEs with the AFT shoes. So they did seem to have like a perceived benefit from them, where they felt at least a little bit easier. We talked to some other like trail runners, people that have run ultra marathons and things like that, and it was one of the most recommended shoes that we saw. So we wanted to look at something that was heavily used in the trail running community to kind of compare to the AFT.
I have a question of this data.
Yes.
So the bottom part, that's from Garmin, you said?
Yes, we had a Garmin watch as well as a heart rate strap that they wore for their trials.
How reliable is that data for things like step length and times on ground?
Yeah, so we find that the data from the heart rate strap does tend to be more reliable than data from the watch, but it's not something that we can know is 100% as of right now compared to taking these metrics in other ways in the lab.
From the ground contact time, do you think that like data could be kind of skewed based on like, I know people have like more fast twitch muscles, so they're like, I don't know, just like not on the ground as much. I don't know.
Yeah, I think that would have more to do potentially with cadence and how fast they're picking their feet back up when they're on the ground, as opposed to the stance time percent.
One more question. I assume you're a runner.
Yes.
Do you have a favorite shoe? Do you have a preferred shoe?
From the trail shoes, just in general, my trainers are Brooks Adrenaline. I've run in for like 6 years now, so definitely heavy preference.
Just out of curiosity, were the subjects mostly male or female?
They were mostly male for this study. We did have one female subject, but as we expand the sample size out, we are looking to have a more balanced look.
To give her her cord and stole that she'll get to wear. Congratulations, and indicate that she's an honor student, and to say a few words about it.
All right. I brought a prop. I don't know if y'all can see this okay. I have this like series of dog motivational posters up in my office. And this one's one of my favorite. So yeah, dog's looking at the toddler in the high chair. And the motto there is recognize opportunity. And I don't think there's any student who's embodied that more than Jordan Sanders in my 10 years of teaching. As she mentioned, this is her third research project. So she started working with me as a sophomore 3 years ago. She's presented at 3 on-campus meetings, 3 off-campus meetings, including the Capitol, and our regional conference where she was voted top 3 in the undergraduate poster competition out of 100-something posters. And she probably would have won, but she had to leave for a track meet and couldn't do the final competition the next day. Yeah, so it's been a privilege to work with Jordan. She's headed off to UT next year for graduate school, and I know she's going to do great things. So join me in congratulating her.